Now, we've talked about less than and greater than, less than or equal to, greater than or equal to, in terms of the special cases. Most of the time, absolute value inequalities are not going to be things you can just think through like that. Instead, we are going to have a process that we follow. If we have an absolute value inequality, we're going to treat it just like it's an absolute value equation at first, in the sense that step one is always going to be isolate the absolute value. Now, you might see some examples that might want to leave the 2 in front or get rid of it by distributing. It's not real distribution. It's properties that we're not going to waste our time going over because we don't need to know them if, when we have something like this, we just go ahead and keep dividing and get the absolute value by itself. It's going to make everything easier in the long run to just keep it all consistent. Isolate the absolute value. Then we're going to have one of two things. We are either going to have absolute value less than, or we are going to have absolute value greater than. So we're either going to have absolute value less than, or we're going to have absolute value greater than. Maybe there'll be or equal to's, maybe there won't be, but we're going to be able to classify it less than or greater than. And then we're going to have a different process for each one. To think about what this process is going to entail, let's break one of these down and dig deep into it. Figure out why it's going to give the things it does, and then we can use the process once we're convinced how and why it works. Let's take a look at, for example, the absolute value of x is less than 3. Okay? On a number line, the absolute value being less than 3 would mean, what is absolute value? Distance from 0. So the distance from 0 is less than 3. So on the positive side, let's shade some things that are a distance from 0 less than 3. I'll give us a 1, a 2, and a 3, like it's a Tootsie Pop commercial. And some negatives, a 1, a 2, a 3. A 3. Okay, here we go. All that stuff, that's like less than 1 away. And now all this stuff is less than 2 away. And all this stuff is less than 3 away. But we don't want to include the 3 because we don't have the or equal to. On the negative side, how much stuff is less than 3 away from 0? Well, this stuff is less than 1 away. And then this stuff is less than 2 away. And then this stuff is less than 3 away. But negative 3 itself, that's a full 3 away. We don't have the or equal to, so we can't put that there. This is all the stuff between negative 3 and 3. This solution could be written as a between inequality, all the stuff between negative 3 and 3. This is really the overlap of two lines. It's the overlap of this with that, and that's a parenthesis. Let me make that more obviously a parenthesis. There we go. Same here. Let me make that more obviously a parenthesis. Overlap, that's an intersection. That's an and statement. What are these? Well, this is x greater than negative 3. And this is x less than positive 3. The intersection of these two lines is how we get this between. And notice there is the x less than 3. And if we wrote this with x on the other side, swap it all. There's x greater than negative 3. The big N stays with the x. The point stays with the negative 3. So that's all a between is. It's an and statement. We can use the fact that this and statement is the answer to this inequality to get a rule for all of these when we have absolute value less than. This means that we drop the absolute value. We drop the absolute value and write it as is. And we drop the absolute value, switch the inequality sign around, so from less than to greater than, and change the positive thing that we have to a negative thing. And we'll get our two answers. In fact, since it's written as an overlap, we could do one better, and we can drop the absolute value sign. We can put another less than in front, and then the negative version of whatever the positive thing is, and then we solve that. In this case, we have the answer. Let's look at a problem, and let's apply our method for absolute value less than. Absolute value of m minus 2 plus 1 is less than 5. Can we use our method yet? No. Why? That's right, because the absolute value is not by itself. We have to subtract 1 from both sides to isolate the absolute value, and we will have the absolute value of m minus 2 by itself with a less than sign. 5 minus 1 is 4. What does our method tell us to do when we have absolute value less than? We're going to rewrite without the absolute value sign. We're going to put another less than, and we're going to put the negative version on the other side. So all that stuff we just did, where I showed you the graph and the overlap and that it's an and statement, that's all well and good. That's where this comes from. That's why this works. So isolate the absolute value, and if it is an absolute value less than, we get a compound inequality. And if we solve this, add 2 to all sides, we're left with m by itself in the center. Negative 4 plus 2 is negative 2. 4 plus 2 is 6. On a number line, we would have a negative 2, a 6, no or equal to. So parentheses, and we shade everything inside. In interval notation, this would be negative 2 to positive 6. Let's look at another. Let's take a look at the absolute value of x plus 4 minus 3 is less than or equal to 10. What is step 1? Isolate the absolute value. Add 3 to both sides. Why? Well, because then we have absolute value less than or equal to 13. And what do we do when we have less than or equal to? We write it without the absolute value sign. We put another less than or equal to in front, and we put the negative version of what our positive thing is. Solve for x, subtract 4 from all sides. We're left with x in the center. 13 minus 4 is 9. Negative 13 minus 4 is negative 17. On a number line, we would have negative 17. We would have positive 9. Square brackets because of the or equal to, and our x is everything in between. We shade inside. In interval notation, we'd have the interval from negative 17 to positive 9. Let's explore greater than. If you need a break, take a break. We've still got another 30-some minutes left. And we're exploring greater than. So let's take a look at, we'll do it the same way. The absolute value of x is greater than 2. If you have a sneaking suspicion that this number line is going to look like the everything else of if this was less than, we know if this was less than 2, we'd end up everything between 2 and -2. If you're thinking this is going to be the rest of it, you are right. So 0, 1, 2, 3, 4, and so on. -1, -2, -3, -4, and so on. Remember, absolute value means distance from 0. So we would be shading things where the distance from 0, the absolute value, is more than 2. So here, the distance from 0 is less than 1. It's less than 2. But here the distance starts being greater than, but 2 itself, the distance would be equal to 2, and that doesn't work. So we'd use a parenthesis, and then this stuff is greater than 2, greater than 3, greater than 4, but that still just means it's all greater than 2. Over on this side, distance from 0 is less than 2. And then here, the distance from 0 would be 2. We can't use that. So parenthesis. But everywhere out here, the distance from 0 is greater than 2. So this is 2 separate intervals joined together as one answer. What does it mean when we bring those in? That's an or statement. This is a union. This interval 2 to infinity is the same as x greater than 2. This interval, -infinity to -2, that's x less than -2. And it's an or statement. An or statement because or is union. And we're taking these 2 intervals and we are joining them together and saying that both of them together make up the graph of where the absolute value is greater than 2. So it is the wing stuff. And let's find out what our shortcut is by looking at this. Well, this one, we can just drop the absolute value sign. X greater than 2. That gives us that one. And then we say or. And we're going to, it looks like, drop the absolute value, switch the sign, and change the positive to negative. That's the same thing we did for the less than, but this one we can't write as one thing. It's not an and statement. It's not an overlap. This has to be written as 2 separate ones. Change greater than to less than, change positive to negative, and that'll give us the other one. Now, what do I mean I can't write this as one thing? Well, if we were to try to join them together so that the -2 was over here, the -2 would have to have the greater than sign. The x would have the little point, and then we'd have greater than 2. Remember, we can't write it this way. This means greater than. There isn't anything that is both less than a negative number, but also greater than a positive number. That's why we can't write it like this. This sort of thing can only be for and statements. This is what we would write for the absolute value of x is less than 2. For greater than, two separate things with an or statement. Drop the absolute value, that's our first. Drop the absolute value, switch the sign, and switch positive to negative. That's the second. Practice time. The absolute value of m minus 2 plus 1 is greater than or equal to 5. Step 1, isolate the absolute value. Get it by itself. And then we make our decision what to do. Absolute value of m minus 2 is going to be greater than or equal to positive 4. Absolute value greater than. Split it into two things. And it's an or statement. First one, we just drop the absolute value. So m minus 2 is greater than or equal to 4. The other one, drop the absolute value, m minus 2. Switch greater than or equal to less than or equal to. Change positive 4 to negative 4. And that's how we make sure we get the wings. Add 2 to both sides. M greater than or equal to 6. Or add 2 to both sides. M is less than or equal to negative 2. How do we graph this? On a number line, we have less than or equal to negative 2. We have a 6, and we are greater than or equal to that. In interval notation, negative infinity to negative 2. Oop, square bracket. Because of that or equal to. Square bracket at 6 to infinity. Remember, parentheses with the infinity, even though we have the or equal to, even though we have the square brackets here, because they are always parentheses for negative and positive infinity. And how do we connect these? With a union symbol. So that is the interval notation form of the answer. Let's look at another one. Let's come to our absolute value of x plus 4 minus 3. This time we'll have it greater than 10. Last time we did one like this, it was less than or equal to. We can start doing the steps a little faster because we know they're the same. Isolate that absolute value first. Absolute value of x plus 4 is greater than 13. Absolute value greater than, two things, or statement. Drop the absolute value. Leave the rest alone, and then drop the absolute value, switch it to less than, switch it to negative 13. Subtract 4 from both sides. X is greater than 9. Subtract 4 from both sides. X is less than negative 17. These are the same things we got when we did it with the less than. But when we did it with the less than, we ended up graphing the middle stuff. Here we have our negative 17 and we have our 9, and we are greater than the 9. We are less than the negative 17. So negative infinity to negative 17, union 9 to infinity. That's going to be our answer there. Okay. Let's kind of build all of this stuff together now. Let's overcomplicate and let's see what happens. Okay. 2 times the absolute value of 6 minus m minus 3 is less than 7. So we want to get the absolute value by itself. Pretend for a moment, this is not the problem, but pretend for a moment we had 2x minus 3 is less than 7. What would we do? We would add 3 to both sides. 2x is less than 10. We would divide both sides by 2. X is less than 5. We do the same things while we're trying to isolate the absolute value. The same things. It's just like solving for the absolute value. So we want to get the absolute value by itself. We've got to get the term with the absolute value in it by itself. Undo minus 3 with plus 3. We're left with 2 times 6 minus m. Next, divide both sides by 2. We get the absolute value of 6 minus m, not 16 minus m, is less than 5. Just like the x version had x is less than 5 because we did the same things. We added 3 to both sides. We divided both sides by 2. We wound up with this. And I'm going to move it up here so that we have room to work on this and finish this problem. We had to get it all the way to the absolute value being by itself on one side. And from there, what do we see? Absolute value less than. So what do? We drop the absolute value. We put another less than in front, and we put the negative version of our positive number from the right on the left, and then we keep going. So far, so good. Here, to get the m by itself, we need to get the minus m by itself, which means we need to get rid of a term that's a positive 6. That's a plus 6. So we subtract. We wouldn't divide because it's not multiplied. We're not getting rid of multiplying. We're also not doing the opposite of subtraction because this is a positive 6 minus m. The minus stays with the m. So we want to get rid of the 6. We do that with minus 6. So 6 minus 6 goes away. We're just left with minus m in the center. Whatever we do in the middle, the minusing of 6, we must do on all sides. Negative 5 minus 6 is negative 11. 5 minus 6 is negative 1. We don't want to solve for minus m, though. We want to solve for m. So we can't just go and change all the negatives to positives and just leave everything else alone. Here, this is still a line that makes sense. Negative 11 is less than something, which is less than negative 1. If we thought about the number line here, again, this is not the answer. I'm just taking a moment to talk about where we are in our work. So if we were thinking about a negative 11 and a negative 1, negative m must be somewhere in here, in between here. The opposite of our answer must be in there somewhere. If the opposite of our answer is over here, where's our actual answer going to be at? Well, the opposite of negative 1 is 1, and the opposite of negative 11 is positive 11. So if the opposite's in here somewhere, the real answer must be over here somewhere. So I'm betting, just based on looking this through, and I'm not using algebra, I'm just looking at the graph and talking about what this means. I'm betting that the answer is going to be this. Oops. Between 1 and 11. So I just realized I cut off here. This is just an 11 with a parenthesis right down here. So 1 and 11. So I can't just change this to positive 11 and this to positive 1 and this to m and leave it less than, because this wouldn't make any sense. This would have to be less than this to use less thans there. But how do we go from a negative to a positive like this? We're dividing both sides by negative 1 or multiplying both sides by negative 1. And what do we do when we multiply or divide both sides by a negative? We would change less than to greater than. And remember, when we write something like this together, we don't want to use the greater than, so we want it in the other form. So if we switch the whole thing around, we have a 1, and then the 1 has a point, and the big N goes towards the M. And then the M has a point, and the big N goes to the 11. And oh, would you look at that? That's the interval from 1 to 11 that we reasoned would be the answer. On a number line, there's 1, there's 11. The answer is the stuff in between. 3 times the absolute value of 5 minus x plus 2 is less than or equal to 14. Go ahead and get started on isolating the absolute value. So hopefully you've been able to subtract 2 from both sides. That gives us 3 times the absolute value of 5 minus x on the left. And then divide both sides by 3. Do not distribute the 3. Divide both sides by 3. You want to get this by itself by making it simpler. Doesn't actually change anything if you try to distribute. It's not even real distribution. It's that weird dome stuff. It's not always going to work. You never know what to expect. The absolute value of 5 minus x is going to be less than or equal to 4. Let's continue to solve this. Still about 15 minutes left. It's an absolute value less than, just like we just did. So we drop the absolute value. We put another less than or equal. Put the negative version of our positive number. Subtract 5 from all of the sides. Negative x in the center, the opposite of x in the center. 4 minus 5 is negative 1. Negative 4 minus 5 is negative 9. This is still making sense at this point. Less thans, we have the least on this side, we have the most on this side. Same order as the number line, basically. Divide all things by negative 1 is going to change minuses to pluses. But it's also, since we're dividing by a negative, going to switch less thans to greater thans. Negative 1 divided by negative 1 is positive 1. When we write it together like this, we got to switch it all around so that they're less thans, but it still needs to be the same. So let's move this 1 all the way to the left, and then we have the point with the 1, the big end towards the x, and then the point with the x and the big end towards the 9 on a number line between 1 and 9. We would have square brackets, and we would be all the stuff in the center. Interval between 1 and 9. Square brackets because of the or equal to. Let's take a look at negative 2 times the absolute value of 3x plus 1 is less than or equal to -4. Now, at first, you might look at this and think it's one of those special ones. It's not, though. And you're going, wait a minute. I was barely following you at the beginning of this, but you said that an absolute value can never be negative. So it can't be less than or equal to a negative, right? This isn't in the final form. So this is why I'm warning, always put it in the absolute value by itself form first. Because look at what happens. To get the absolute value by itself, we have to divide both sides by -2. Dividing both sides by a negative is going to change less than or equal to greater than or equal to. We're just going to have the absolute value of 3x plus 1 on one side. On the other side, negative divided by negative is positive. So -4 divided by -2 is +2. So here we have absolute value greater than or equal to +2. When it's absolute value greater than, we split it into two things. With an or statement, one, we just drop the absolute value sign and keep everything as is. 3x plus 1 greater than or equal to 2. Or the other one, we drop the absolute value, we change greater than to less than, or equal to in this case, and we change +2 to -2. If I subtract 1, I get 3x is greater than or equal to 1. If I divide both sides by 3, I get x is greater than or equal to 1/3. Or the other side, subtract 1 from everything. I get 3x is less than or equal to -3. If I divide both sides by 3, I get x is less than or equal to -1. Don't switch the sign just because this is a negative. We're dividing by a positive. It's only when we divide by a negative. Negative divided by positive doesn't change the sign. So let's write our answers. I'm out of room, so I'm just going to move this up. X greater than or equal to 1/3, or x is less than or equal to -1. On a number line, that's a greater than or equal to. Just moving it down out of the light spot. On a number line, we would have -1, and then we would have +1/3. We would have square brackets for our equal to, and we're greater than 1/3 or equal to, and we are less than or equal to -1. So -infinity to -1, union 1/3 to infinity.
We want to solve for x. The absolute value of x plus 4 is less than 6. So we want to make that x plus 4 is between -6 and 6. Drop the absolute value symbol, add another less than onto the left, and then since we had 6 on the right, put -6 on the left. and then solve this. To get x by itself in the middle, we need to subtract 4 from the middle. Whatever we do in the middle, we have to do in all parts. So subtract 4 everywhere. -6 minus 4 gives us -10. It leaves us with just x in the center. And then 6 minus 4 on the right gives us 2. So in interval notation, our answer would be -10 and 2 inside of parentheses. Why parentheses? Because there is no or equal to. So the -10 on the left takes a parenthesis, and the 2 on the right takes a parenthesis. Another one. The absolute value of x minus 3 plus 6 is less than or equal to 7. We know how to solve an absolute value less than. We do not know how to solve an absolute value plus 6 less than. So we need to get rid of that plus 6. We do that by subtracting 6 from both sides, which gives us absolute value less than. We know how to solve that form. Absolute value of x minus 3 is less than or equal to 1. No difference with the or equal to, except when we get to the end and do our answer, we'll have square brackets instead of parentheses. So drop the absolute value, add another less than or equal to onto the left side, and since we had a 1 on the right, we'll have a -1 on the left. X minus 3 is between -1 and 1, including both values. To get the x by itself in the middle, we want to get rid of -3, so we need to add 3, which means we need to add 3 everywhere. -1 plus 3 is 2. X minus 3 plus 3 just leaves us with x, and 1 plus 3 is 4. So we get x is between 2 and 4, including both values. In interval notation, that is 2 on the left with a bracket, 4 on the right with a bracket. And if we wanted to see that graph, it would look like this. Maybe you need the graph still to get the interval notation. If so, no problem with that. And of course, one that has some sort of trick that we don't want to fall for. This says that an absolute value is less than a negative number. Well, an absolute value can never equal a negative number. We've seen that in the past. If it can't equal a negative number, it certainly can't be less than a negative number. Everything less than a negative number is negative, so it can never be less than a negative. No solution. If you attempted to drop the parentheses, add another less than, you would notice, hopefully, that on the right you already have a negative, and it wouldn't make any sense to put a +2 on the left side of a less than statement. So an absolute value cannot be less than a negative number since it can't be negative. Be so careful that it is saying less than the negative number. Something different happens if it's greater than a negative number. And hopefully we take a look at that in just a little bit. But for now, an absolute value can't be less than a negative number since it can't be negative. No solution. Okay. This looks scary. The absolute value of the fraction where the top is 2 times the quantity x plus 1 and the bottom is 3 is less than or equal to 0. Now remember, it couldn't be less than a negative number. Less than or equal to 0 means it's either 0 or it's negative. So since the sign means less than or equal to, and the absolute value of any expression will never be less than 0, it can equal 0. And equaling 0 is the only thing that would make this statement true. So let's change it from less than or equals 0 to just equaling 0. And then we can get rid of the fraction by multiplying both sides by 3. Distribute the 2. 2x plus 2 equals 0. Because remember, when we have the absolute value equaling 0, there's only one solution to that, and it's the solution we get by completely ignoring the absolute value symbols. Solving, we would subtract 2 from both sides. 2x equals -2. Then we would divide both sides by 2 and get x equals -1. Even though this started out as an inequality, there is only one answer. The solution set is -1. So let's take a look at the absolute value of 10 plus 3x, and then outside the absolute value plus 1 greater than 2. We know how to do absolute value greater than. We do not know how to do absolute value plus 1 greater than. So we need to get rid of that plus 1. Subtract 1 from both sides, and we get the absolute value of 10 plus 3x is greater than 1. Two equations. One of them we get by dropping the absolute value sign completely and reading as is, so 10 plus 3x greater than 1. The other one, drop the absolute value sign, switch greater than to less than, switch positive to negative. So 10 plus 3x is less than -1, or it's an or statement, 10 plus 3x is greater than 1. So interesting, that comes back around. Absolute value less than was a between. Betweens were ands. Absolute value greater than is an or. It splits into two separate inequalities. Either way, whether you want to do the first one first or the second one first or both at the same time, you're going to be subtracting 10 from both sides as the first step in both. So -1 minus 10 is -11. 1 minus 10 is -9. You're going to divide both sides by +3 to get the x by itself. It does not matter that the 11 is negative or that the 9 is negative. What matters is that we're dividing by a positive, so the sign does not switch. X is less than -11/3, or x is greater than -3. That's what we get when we divide both sides of both equations by 3. Now, to put this one in interval notation, we're going to use the union symbol. Remember, or is a union. We have two separate intervals here. We have one interval from -∞ to -11/3. We have another interval from -3 to +∞. Since we have two separate intervals as part of the answer, but an or means we have to take both, we connect them with the union symbol. One of our trick problems. The absolute value of x plus 2 is greater than or equal to 0. Well, remember, the only big rule about absolute value is that an absolute value can never be negative. It can always be greater than or equal to 0, though. All absolute values are greater than or equal to 0. Since this is always true, the solution is all real numbers. Any value for x that we would substitute into the inequality will give us a true statement. Our last example, before I switch to the last example, I want to say that if this had said instead of greater than or equal to 0, greater than a negative number, even though they can't be negative, they're always greater than negatives. So even greater than a negative number would be all real numbers, not no solution. Okay. Last example, the absolute value of 7 plus x over 2 is greater than or equal to 4. Don't let the fraction worry you. Fractions aren't going to harm you, not while I'm around. Take what is inside and have it greater than or equal to 4. Just drop the absolute value for one of them. For the other one, drop the absolute value, switch the sign around, and make positive negative. So 7 plus x over 2 less than or equal to negative 4, or 7 plus x over 2 greater than or equal to 4. No matter how you approach this, whether you like to get rid of the fractions by multiplying by the LCD, or you just take care of it normally using fractions, it's the same either way here. The first step is to multiply by 2 on both sides to get rid of dividing by 2. So 7 plus x is less than or equal to negative 8, or 7 plus x is greater than or equal to positive 8. Negative 4 times 2, and 4 times 2. Finally, subtract 7 from both sides to get the x by itself on the left. Negative 8 minus 7 is negative 15. 8 minus 7 is positive 1. So we end up with x is less than or equal to negative 15, or x is greater than or equal to positive 1. Again, this is 2 separate intervals, but we need them both to be a part of the answer. So our first interval is from negative infinity to negative 15. Our second interval is from 1 to infinity. We connect that with the union symbol. And what does this look like as a graph? It's just our 2 intervals grafted. Graphed, not grafted. Graphed on the same number line. X less than or equal to negative 15, x greater than or equal to 1. And that is it for this topic. Number 8, we want to graph the solution set of the inequality and write it in interval notation. We're given the set of all x such that x is between 0 and 4, including 0, not including 4. Or 0 is less than or equal to x is less than 4. Well, whether or not there's an or equal to tells us whether we use a bracket or a parenthesis. If there is an or equal to, it's a bracket. If there's not an or equal to, it is a parenthesis. So at 0, there is an or equal to, so that's a bracket. At 4, there is no or equal to, so that's a parenthesis. So x, the shading, is between a bracket at 0 and a parenthesis at 4. The interval is bracket 0, 4 parenthesis. So C with this order of the answers. Your answers were likely in a different order because they were randomized. Number 9, list the elements of the set. We're given if A is the set containing negative 9, negative 8, negative 7, and negative 4, and B is the set containing negative 11, negative 9, negative 8, negative 6, list the elements of A intersection B. That's not a union. That's the upside down union symbol. That's intersection. And we remember that an intersection requires the number to be in both sets.
Union would be one or the other. Intersection is and. It has to be in A and in B. And the only numbers that are in both A and B are -9 and -8. So -9, -8 in a set, that is the answer. Number 10. Solve the compound inequality and graph the solution set. We're given 6x minus 4 is less than 2x, or -3x is less than or equal to -9. This is an or statement, which means we solve them both and then both answers get graphed on the same number line. It's not where they overlap. Overlap would be an and statement. Or statement, they both get graphed. So we start with 6x minus 4 is less than 2x. We solve it just like we would an equation. We want to get the x's on the same side. So I go ahead and subtract 6x from both sides. Why did I subtract 6x from both sides and not 2x from both sides? Well, I could have done 2x, but that would give me extra steps because then I would still have to move the numbers to the other side. Moving the 6x over gets the x's on one side and numbers on the other side in one step. So 6x minus 6x cancel each other away, leaving us with -4 on the left. 2x minus 6x on the right gives us -4x. So -4 is less than -4x. Divide both sides by -4 to get the x by itself. We do get the x by itself on the right. -4 divided by -4 is +1. Negative divided by negative is positive. And the sign flips from less than to greater than because we divided by a negative number. We divided by -4 on both sides. That flips the inequality sign. So we have 1 is greater than x. But to help us graph, we want our x to be on the left side, so we flip the whole thing around. X is less than 1. That would be the interval from -infinity to 1 with a parenthesis because there's no or equal to. Moving on to the second inequality, second part of the compound inequality, we have -3x is less than or equal to -9. We're going to go ahead and divide both sides by -3 to get the x by itself. -3x divided by -3 leaves us with just our x. -9 divided by -3 gives us +3. Negative divided by negative is positive. And the sign flips from less than to greater than because we divided both sides by -3. Whenever we multiply by a negative or divide by a negative, we have to flip that sign. So x is greater than or equal to +3. That's the interval from 3 to infinity with a bracket at 3. It's a parenthesis at infinity because the infinities always take parentheses no matter what. Put them both on the same number line, and we get answer choice A here. Again, for you, maybe it was B, C, or D. But whichever one looked like this is the answer. Number 11. We are given the compound inequality 7/2 x minus 2 is between 5 and 12, including 5, not including 12. Or 5 is less than or equal to 7/2 x minus 2 is less than 12. This is a 3-sided inequality. Our rules of algebra still apply. It's just now whatever we do on one side, we do to all the other sides. Specifically, whatever we do in the middle, we do on the left and on the right. And in the middle, we're trying to get the x by itself, which means we need to get the 7/2 x by itself, which means we need to get rid of -2. We undo subtracting 2 by adding 2. Whatever we do in the middle, we do on the left and on the right. So that just leaves us with 7/2 x in the middle. 5 plus 2 is 7. 12 plus 2 is 14. 7 is less than or equal to 7/2 x is less than 14. Now we need to get rid of multiplying by 7/2. We do that by multiplying by the reciprocal, 2/7. So multiply by 2/7 in the middle, multiply by 2/7 on the left, multiply by 2/7 on the right. That leaves us with just x in the middle. 2/7 times 7 is 2. 7s cancel. 2/7 times 14 would be 28/7 would be 4. So 2 is less than or equal to x is less than 4, or x is between 2 and 4, including 2, not including 4. On the left, there's a or equal to sign. That means we use a bracket. On the right, there is no or equal to sign. That means we use a parenthesis. The shading is x, the interval. So x is between a square bracket at 2 and a parenthesis at 4. The interval is square bracket 2, 4, parenthesis. The shading is between. So here the answer would be B. Number 12. Solve the absolute value equation. Absolute value of 4x plus 9 plus 6 equals 4. This one was a tricky one. You don't go through all the steps of solving. What happens is when you start by subtracting 6 from both sides, you get the absolute value of 4x plus 9 is equal to -2. Absolute values can never be negative. Absolute values are always positive. So there is no solution. The empty set is the answer for this one. Number 13. The absolute value of 3x plus 6 equals 9. So this one, we do have to go through all the steps. We start by subtracting 6 from both sides, which gives us the absolute value of 3x plus 6 equals 3. Now that means that 3x plus 6 must be 3, or it must be -3, because those are the two things where we can take an absolute value and get 3. So we set up 3x plus 6 equals 3. 3x plus 6 equals -3. We solve them both, subtract 6 from both sides everywhere, then divide both sides by 3. With 3x plus 6 equals 3, that gives us 3x equals -3, and then x equals -1. For 3x plus 6 equals -3, that gives us 3x equals -9, and therefore x equals -3. So -1, -3 are the answers. Number 14, solve the inequality and graph the solution set. This is an absolute value less than. Absolute value of x minus 19 is less than 5. Absolute value less than has a particular form to solve. That's where we write it without the absolute value and then put the negative of the number on the other side. So we end up with x minus 19 is between -5 and 5. Whatever we do in the middle, we do everywhere else. We want to get the x by itself. We want to undo subtracting 19, so we add 19 everywhere. That leaves us with just x in the middle. -5 plus 19 is positive 14. 5 plus 19 is positive 24. So x is between 14 and 24. There's no or equal to's, so those are parentheses for the interval. 14, 24. The answer here is D. And finally, number 15. The absolute value of 4k plus 6 is greater than -9. Again, this is a tricky one. Don't just blindly set up the form for solving absolute value greater than and make your two inequalities. All absolute values are positive. Therefore, they are always greater than -9. So this is always true. The answer is all real numbers, -infinity to infinity. A here. Okay, that's it.